Good morning. Today we are going to do Chapter 2, Section 2, Day 2, describing distributions of data. Let me start the slideshow. Okay, here we go. So the 5-number summary is perfect when the data is skewed, but it's not the most common numerical description. The mean and the standard deviation are the most common numerical description. But if the data is skewed, the median and the 5-number summary often represents center better than the mean. Okay, yep, so this is a joke from it's like a little comic from the textbook that I thought was kind of funny for right here. Old Bob drowned due to being ignorant of statistics. He thought it was enough to know the average depth of the river. Well, the average depth of the river is not the same depth the whole way through. So even though the river might have averaged at, I don't know, let's say 3 feet, that doesn't mean there's not a section that's deeper. Okay, so the mean. The mean is abbreviated X bar. So there's a bar on the top of it right here. And that's just read X bar. It's an average of the set of observations. So the formula is we take the sum of the observations and divide by n. N is the number of observations. The mean tells us how large each observation is in the data set will be if the total is split equally among all observations. Okay. Mean and median both measure center. The median is resistant to outliers. The mean is non-resistant, meaning an outlier is going to have a big effect on the mean. When the distribution is skewed, the median is a better measure of center. Well, this is my example right here. Okay, so for example, here's my first set of data, 0, 1, 2, 5, 7, 150. So if I'm looking at this data, can we agree that 150 is going to be an outlier if we go through the process of figuring out what the interquartile range is and doing Q3 plus 1.5 times the IQR? We can be pretty sure that 150 is going to be bigger than that number because it's so far off the rest of the data. So here we go. We take the average, and that's going to be 27.5. So if I add all those numbers up, divide by 6, it's going to give me 27.5. The median, we're going to put the numbers in order, find the middle number. I have 2 numbers. I'm going to average them, and that means my median is 3.5. Can you see how big of a difference that is? So this 150 is skewing the data towards the right. The 27.5 is a lot bigger than this 3.5. So if I'm looking at a number line, right? If I'm looking at a number line, 3.5 is going to be over here where most of the data is, right? Isn't most of my data in this smaller left-hand section? And then this 150 is way over here, bringing the average over to 27.5. So this outlier pulls the average towards the tail of the data, making this skewed to the right. Okay. So now let's eliminate the outlier. Let's just get rid of it. I'm going to take off that 150 and see what happens. Now most of my data is between 0 and 7. So I'm going to find the average, and the average is 3. The middle number, put the numbers in order. My middle number is 2. Now they're not exactly the same. 2 and 3 are not the same number, but they're pretty close to the same number. So when I draw that, most of my data is centering around this. Okay, so the average is 3 and the median is 2. Okay, so most of my data is right there in the middle. I've got the same sides on both sides. So this data is going to be what we call symmetric because the outlier is not there to skew the data. Okay, so with the outlier, the X bar and X tilde, the mean and the median, were very different. But without the outlier, they're very similar. So the mean and the median will be relatively the same. There are no outliers that will affect either. So if the distribution is symmetrical, the mean and the median are going to both be in the middle. Okay, so in the symmetrical data, the median and the mean are both right there in the center. They might not be exactly the same, but they're close enough to the same that we can just put them right there in the middle. If we're skewed to the right, the mean is greater than the median. The larger outliers pull the mean higher than the median. So in a skewed to the right, the tail is on the right-hand side, the mean is going to move towards the tail. The median moves a little bit off of this peak, but not as much as the mean does. If we're skewed to the left, the mean is less than the median. The smaller outliers pulls the mean lower than the median. So in this situation, which is the mean? Is the mean A or is the mean B? The mean moves in the direction of the tail. So which side is the tail on? My tail is over here on the left-hand side because I'm skewed to the left, so my tail is on the left, which means that A is going to be my mean. My X bar, and it means that B is going to be the median, which notation-wise, my median is X tilde. Okay, mean and standard deviation. The standard deviation lets us know how far away from the middle most of the data is. So do you see how in this first symmetric data, we've got a pretty big, wide range of where the data is. So my standard deviation is pretty big, okay? The standard deviation, one standard deviation away is where we change from frowny face to happy face. So right here, we're concave down, and then right here, I switch to concave up. So that's that point. And then right here, do you see we go from concave down to concave up? So if this is, let's say this standard deviation is 4, this standard deviation would only be 2. It's half as big. This distance, right, oops. Let me undo that. I didn't mean to make that line so big. Okay, let's try that again. So this line right here is a lot smaller than this line right here, meaning that this data is clustered around the mean closer. Okay, so all of the data is closer to the average, and you can see how that standard deviation is squished in, so that all the data is squished in. It makes this peak higher. As I flatten this peak, my data is spread more apart, making my standard deviation bigger. Okay, the standard deviation measures the average distance of the observations from the average, from the mean. S is your sample standard deviation, and sigma, that's a little circle with a line on top of it. It's the lowercase sigma in the Greek alphabet. It means the population standard deviation. So there's a formula. Okay, this is the first formula that we're going to get into for the year, and you're going to need to memorize it. Here we go. So S, meaning the sample standard deviation, this symbol right here is capital sigma. It means the sum of x minus x bar squared divided by n minus 1, where n is the number of observations. Okay, again, memorize the formula. The variance is the standard deviation formula that's not been square rooted. It's just what's under the square root. All right, so here we go. Find the standard deviation of the data set. So the first thing we're going to do is we're going to find the mean. So I'm going to take those numbers and I'm going to add them together, and I'm going to divide by 5. That's the number of numbers I have. And my mean is 3. And now we're going to look at the formula. Okay, so x minus x bar, so that'll be x is my 0, minus the x bar is 3, and then I'm going to square it. And then I'm going to do 1 minus, because 1 is my next data point, minus the average, which is 3, and I'm going to square it. And I'm going to do 3, the next data set, minus my average is 3, and then square it. I'm going to do that for all of my data points. And then I'm going to figure out what those differences are, and I'm going to square those numbers. So negative 3 squared is 9, and I'm going to add those numbers up. Okay, so when I add 9, 4, 4, and 9, I get 26. So 5 is the number of data points that I have, minus 1 gives me 4. So I'm going to divide that 26 by 4, and I get 6.5. And then I square root that number, it gives me 2.549. Now, I like to organize the information. All of this information is the same thing as what I have here. I just organize it in a table so I don't have to write that out, because bigger data sets, this can get pretty involved. So the first thing I do is I take all of my x's and put them in a column. So 0, 1, 3, 5, 6, there's my x's right here, 0, 1, 5, 3, 6. And then I'm going to take my x and subtract the average. There should be a bar on top of those. It kind of got a little cut off. There's a bar on that one too. So 0 minus 3 is negative 3. And then I'm going to take that negative 3 and I'm going to square it, and it gives me 9. And then I'm going to do that for all of my x values. So 1 minus 3 is negative 2. Negative 2 squared is 4. And then I'm going to take all of these values that I have here, the 9, 4, 0, 4, and 9, and add them together. Okay, and that's where I got this 26 from. So I'm doing the same process that I did over here. I've just organized all the information so I can find it. It's a little cleaner and easier for me to read. It's faster for me to grade it this way too. So basically, I'm just going to skip writing this all out. Okay, and we'll do an example in a minute. Another example, rather. So some properties of standard deviation. When S is 0, there's no variability. So if the standard deviation is 0, all of the observations have the same value. There's no difference. There's no variability in what my x values are. Standard deviation has to be bigger than or equal to 0. Standard deviation is never negative. It is always, always, always positive. The larger S gets, the more spread out from the mean the observations are. The smaller it gets, the closer together the observations are. So let's look at an example. This is page 70, number 33. A person's metabolic rate is the rate at which the body consumes energy. A metabolic rate is important in the studies of weight gain, dieting, and exercise. Here are the metabolic rates for 7 men who took part in a study of dieting. The units are calories per 24 hours. These are the same calories used to describe the energy content in food. Use the formula to calculate the mean and interpret this value. So for the mean, I'm going to add together my numbers that I have here. There they are right there. I'm going to add them together. And then I'm going to count 1, 2, 3, 4, 5, 6, 7. So I'm going to divide by 7, and that gives me a mean calorie of 1,600. In words, this means that the average metabolic rate of the 7 men in this study was 1,600 calories. Meaning if all 7 men were to have consumed the same number of calories, it would have been 1,600. Okay, same question, but this time we're going to calculate the standard deviation. Okay, so here's my numbers, and I'm just going to write the formula down for you right here. Okay, hold on a second, that was too fast. So my mean was 1,600. So this X bar right here, I'm going to come back right here, and I'm going to change my color. So the X bar right here, we calculated on the last slide to be 1,600. So I'm going to organize this data. First thing I'm going to do is write down my X value. The first X value was 1792. And then I'm going to take that X value and subtract the average. So I'm going to do 1792 minus my 1,600, and that's going to give me 192. And then I'm going to take that value, so the X minus the X bar, which we just found was 192, and I'm going to square it. That's what this means right here. We're going to subtract first and then square. So I'm going to take that 192 and I'm going to square it. And I can't square that in my head. I need a calculator. I got my calculator. 192 squared is 3 6, 8, 6, 4. And now I'm going to do the next one. The next one is 1666. So I'm going to write that x value down, 1666. And I'm going to take that 1666 and I'm going to subtract the 1600. And when I subtract those, I get 66. And then I'm going to take that 66 and I'm going to square it. And 66 squared is going to give me 4, 3, 5, 6. Okay, pause the video and you try 1362. What do you get when you do 1362? Okay, did you get 56,644? Okay, if you did, perfect. If you did not, go back and check your answer. If you had a negative sign right here, remember that when you square a negative number, it should be positive, okay? The calculator, if you type in negative 238 squared, will tell you that the answer is negative. The calculator is wrong. A negative times a negative is a positive. If you want to make the calculator give you the right answer, put that in parentheses before you square it. All right, so then you're going to keep going, okay? I'm not done yet. I'm just out of space. So I'm going to clear all this out, and we're going to look at all of these, okay? So if I finish the rest of them, I get these numbers, okay? The next step is to take all of these squared numbers, all of these answers that I have in this third column, and this means right here, this part of the formula means that I'm going to sum. So I need to take all these numbers and I need to add them. I need to add that column. So when I do that, I get 214,870. Now where did this 6 come from? How did I get 6? Okay, so the denominator over here says n minus 1. So I have 1, 2, 3, 4, 5, 6, 7. So 7 minus 1 is going to give me 6. I'm going to divide those numbers. So the 214,870 divided by 6 is going to give me 35811.67. And then I take that number and square root it, and I get 189. Oops. Okay, so the 189 is the standard deviation from average. Okay, so if you do this in the calculator, if you enter the data into L1, press step, arrow over to calculate, go down to one variable stats, select standard deviation, and then press enter. You're going to look for, go down to variable 1, press enter here. So here's where you want to press enter. And it's going to give you a whole bunch of information. The X bar that it gives you was your average. The S sub X is your standard deviation. It'll also give you your population standard deviation. And if you scroll down, you're going to see the median. You're also going to see the quartile 1 and the quartile 2. You'll see the min and you'll see the max. If you have any questions how to put in your calculator, come see me for tutorials and we'll go over it. Okay, so let's look at these data sets right here. So A, B, and C. The average for all of these data sets is the same, but look at the data. The data is very different, right? So which one has the smallest standard deviation? All of the data is clustered around the 4.5 right here in A. So this is going to be the smallest standard deviation. Which one's going to be the largest standard deviation? So this one has my standard deviation right in here in the middle, and my distance from the middle to where all the points is going to be the biggest. So this one is going to have the largest standard deviation. This one's going to be in the middle. It's going to be smaller than this one, but bigger than A. B is going to be in the middle because my data has a standard deviation of a bigger than it does right here. Do you see how the distance from the middle to the outside data is going to be a little bit different, right? This one's going to be the biggest, this one's going to be the second biggest, and this one's going to be the smallest. All right, so let's do an example. So first it says make a dot plot, so let's review that. So if I make a dot plot, I'm going to put a point on 3, I'm going to put a point on 5, another at 5, another at 7, and 8, back down to 2, up to 7, and another at 5. So if I look at my data, I have this shape that looks something like this. It's roughly symmetric. I've got most of it right here in the middle, and I've got some on the left and some on the right. Okay, so N. N is the number of data points. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8. So N is going to be 8. X bar is when I take all the numbers and add them together. It doesn't matter if I put them in order for this. I only have to put the mean D in order. So then I'm finding the mean. It doesn't matter if it's in order. So I'm going to do 3 plus 5 plus 5 plus 7 plus 8 plus 2 plus 7 plus 5. And that's going to give me 42. And I'm going to take 42 and I'm going to divide by 8. And that's going to give me 5.25. Now we're going to complete the table at the right. It doesn't matter what order I put the x's in. You're welcome to put them in order. You don't have to. I'm just going to put the x's down here. 3, 5, 5, 7, 8, 2, 7, and 5. And then I'm going to take each x and I'm going to subtract the average, and then I'm going to square it. So I'm going to do 3 minus 5.25, and that's going to give me negative 2.25, and I'm going to hit square it on my calculator. Now remember, a negative times a negative should be a positive, and my answer over here is going to be 5.0625. Now make sure you're trying a couple of these on your own. So I'm going to do another one. Here we go, 5 minus 5.25, and that's going to give me negative 0.25. And I hate that it keeps doing that. And I see that I have some more 5s. So I'm going to put that answer in for all of my 5s. So I don't have to redo this another time. Okay, so I've got negative 0.25, and then I'm going to square that. Okay, negative 0.25 squared is 0.0. .0625, and I'm going to write that answer for my other 5s. 0.0625. Okay, now I need to do 7. So pause the video. Make sure that you're trying a couple of these on your own, and then come back to me and see if you got it right. So 7 minus 5.25 is going to give me 1.75, and I've got another 1.75 down here, and I'm going to hit squared on my calculator, and that's going to give me 3.0625, and over here I've got 3.0625, and now I'm going to do 8. 8 minus 5.25 is 2.75, and we're going to square that, and that's going to give me 7.5625, and we're going to do 2 minus 5.25 is negative 3.25, and I'm going to hit squared, and it's going to give me 10.5. 5, 6, 2, oops, 5. Oh, that looks like a 1. Okay, hold on a second. Let me try to make that better. There we go, 2. Okay, so we're not done yet. The next step is to take all of these numbers right here. So I'm going to take all of these numbers right here. And this symbol means to add. So I'm going to find the sum of all of these numbers. Okay, so here we go. 5.0625 plus 0.0625 plus 0.0625 plus 3.0625 plus 7.5625 plus 10.5625 plus 3.0625 plus 0.0625. Enter. And that's going to give me, so this sum right here is going to be 29.5. Don't worry about this right here. Okay, it's always going to be there. You don't actually have to find it. So here we go. This is going to be 29.5. So now it wants us to find the variance. The variance is that sum, so that's going to be 29.5 that we just found. And now I'm going to divide by n minus 1. So I'm going to count. Oh, there's my n, 8. 8 minus 1 is 7. So 29.5 divided by 7 is going to give me 4.214. Remember, we agreed to 3 decimal places if at all possible. So I've got 4214. Now to find S, we're going to take that number that we just found right here, this 4214, and I'm going to square root it. So the square root of the 4214 is, oh goodness, I really don't know. Well, that sucked. Not going to rewrite all that. 2.0. Why does it keep doing that? 2.053. So that's my standard deviation, is the 2.053. Now there are 2 more examples, and I'm going to ask you to work through those on the practice problems, but it's the same thing like we just did right here. You've just got 2 more. So use your paper that I have on the Google Classroom. You're welcome to use that and practice doing this, and then I'm going to ask you to put your answers in on the practice problems. Okay, so quick review. We're going to decide, is the distribution symmetric or skewed? And then we're going to decide whether we should use the mean or the median for the center. The spread, we're looking at the standard deviation or the 5-number summary. If you use the mean to measure center, then use the standard deviation to measure spread. If you use the median to measure center, use the 5-number summary to measure spread. Remember, the mean is not resistant and will be affected by outliers. The mean will be pulled in the direction of the outlier, which is what makes the tail of the data. So, comparing distributions. If I have a categorical variable versus a quantitative variable, remember a categorical variable is when my variables are words or numbers that can't be averaged, and a quantitative variable is a number that can't be averaged. In your quantitative data, remember this is numbers that can't be averaged. You're going to plot either a dot plot, stem plot, or a histogram, and you're going to interpret what you see. What is the shape? What's the center? What's the spread? What are the outliers? And then you're going to either do the average and the standard deviation, or you're going to do the mean. I said that wrong. The average or the mean and the standard deviation, and the median, I didn't put that in there, the median with the 5-number summary. If your data is categorical, you're going to either use a bar graph or a circle graph. That's it. We can't do anything else with categorical data. All of the center, spread, outliers, all of that stuff, the mean and the median and the standard deviation and the 5-number summary, all of that has to be for quantitative data. All I can do for categorical is make a bar graph or a circle graph. Okay, so your homework, which is your practice problems, I didn't change this. Don't call it homework number 9. I used these problems to make practice problems 2.2 day 2. All right, guys, have a good day.